Hey guys, this recording is to explain task 10. It's the final task in our SpringStat project. So I have my SpringStat project file open, and if needed, you guys should also open your 10.2 class notes to reference any of the work dealing with the chi-square test of independence, because that's what we're doing in this task. On to step 2. In my Google Sheets file, I'm going to add a sheet and name it task 10. All right, and then I'm going to go on to instruction number 3. I have to go into both my first and second states, and my first state was Tennessee. I'm going to grab column E for gender, copy paste it into task 10's column A. Then I'm going to go to the Virginia state. I'm going to get column E. I do realize I'm going to get the word gender in here as well, but I'll worry about that after. So let me do a copy paste on that. I'm pasting that under the rows I have for Tennessee. So I'm just putting both states in here. All right, and then I'm going to go into Tennessee, and I'm supposed to grab column BF. BF, it's pretty far toward the end here, and it's the column called preferred status. Let's see here, it's BF, preferred status, and I'm going to do a copy, and into the task 10 sheet, column B, do a paste. Okay, and then back to the Virginia data set. Also need to go get column BF here at the end. Copy that. Task 10, under the rows I just have here. Let's paste. Okay, so this gender and preferred status duplicate row header, I'm just going to delete this row. Oops. Let's undo that, I hit the wrong thing. Just right-clicking, delete row. All right, so instruction 4 is about fixing any entries because this is paired data. These were all the Tennessee students and Virginia students who reported their gender and whether they wanted to later in life be healthy, happy, rich, or famous. If anybody didn't answer one of the two or both questions, you have to delete their row because that destroys the pairing of this data. So there's going to be probably a fair number of rows for me to delete. You'll have to do the same with your two states. So luckily the data sets aren't too large. The most anyone would have is, I guess, about 100 rows of data. So you just have to scroll through and find any empty rows. I'm right-clicking and I get the option to delete the row. So I have a few more spots to delete. All right, there we go. So I have a total of 32 rows, which means I have 31 observations. Instruction number 4 is done. So the objective of the task, next to this arrow here, is to see if I have a relationship between gender and preferred status. So in order to do that, I've got to make myself a contingency table. These tables are called pivot tables in Google Sheets. So to get a pivot table, I'm going to have to click to highlight the data in columns A and B. And I'm not positive, but I believe here, I'm holding down my Shift key. I should only get to the end of my data here. Once I have that highlighted from the beginning to the end of my data that's in the two columns, I'm going to go to the data drop-down and grab Pivot Table. And then the instructions, number 5, say click existing sheet, and let's make it put this table starting in cell D1. Okay, I'm going to have to move the screen over here a little bit so you can see the pop-up. So a pivot table editor pops up, and the next things you have to do to create the frequencies you need is you have to tell it gender is going to be rows, preferred status is going to be columns, and then next to values, press the add button and pick preferred status again. And now we show you that the contingency table along with its totals are created. So amongst the female responders, amongst all of the responders, 2 were female who said famous, 12 were female who said happy, 13 were female who said healthy, etc. And we're going to seek for an association between these. Well, now in stats, we usually do some sort of exploratory data analysis first by graphing and then by some more formal inference procedures. Now the graph I'm going to ask you to insert here next to the instructions number 6 is the 100% stacked column graph. So in order to do that, I have to click and highlight the rows and columns, excluding the totals in the margin to select my data, and then insert chart. So I'm going to go here and I'm going to select this, but notice I'm going to leave off the totals. And I'm going to go to insert chart and see what pops up. Okay, so not the chart I want. This is known as a side-by-side bar graph. Drag it over here in the view a little bit. I prefer, instead of looking at the counts of the responses, because there were way many more females than males, often that's the case that the 2 group sizes are different, I would rather see under chart type the thing down here called 100% stacked column chart. And now I get a better view of the percent differences in the breakdown of rich, healthy, happy, and famous. A couple other things over here. I'd like you to go to the Customize tab, and under Chart and Axis Title, I'm going to change the chart title to instructions here. Sorry, I'm at instruction number 7. I want to customize the chart style to 3D and the chart title to preferred life status for females and males. Okay, so sorry, first in the chart style, I have an option to show this in 3D, which is pretty cool. And in chart axis titles, like I said, preferred, spelling here, preferred life status for females and males. Okay, so I've got a meaningful title on my graph and I have it in 3D. So then I'm asking you, now that I see this graph, I've done the customizing, now that I see this bar chart, do I see some similarities and differences in the distribution of preferred status within the genders? What strikes you as being similar versus different? Well, in both, there's a similar percent. It's a little bit hard to read, but not that difference if I'm pointing out similarities. Similarities, maybe the only one I have is that being famous wasn't really very important to males or females. As far as the happy subgroup, there's a much higher percent of females who want to be happy than males. None of the males, at least in my 2 states, reported wanting to be healthy later in life. And then as far as rich goes, a much lower percentage of females than males reported wanting to be rich. So when I say point out the similarities and differences, you're just looking at the size of the stacks in this 100% stacked set of columns for the 2 genders. Okay, on to instruction number 9. So now I'd like you to go over to cell J1 through M14. I just noticed that I'm probably going to change this to K1 so that I'm not too close to the column here, column I, that I have right here. Actually, since the instruction's already there and I'm already speaking, I'll just stick with what I got. So I'd like you to type in cell J1 this chart right here, the instructions at the top of page 18. So I have some typing to do. So as far as the cells are in these contingency tables go, it's female famous, and then it's female happy, and then it's female healthy. I'm pretty sure this just all came up in alphabetical order. And then it's female rich. The next contingency table cell would be male famous, male happy, male healthy, and male rich. Okay, and then I wanted you to type the word observed, and then a title for expected, and then a column that's going to have, in order to produce the chi-square statistic, the observed minus the expected squared. Squaring in a spreadsheet is the caret symbol with a 2, divided back by the expected. Okay, so for the observed, I wrote in the instructions, just enter the values from your pivot table. So the pivot table told me in my data set there were 2 females who wanted to be famous, 12 who want to be happy, 3 rich, 3 healthy, and 1 rich. Then I'm on the males. I have 1 who wants to be famous, 7 who said happy. I have 0 on healthy and 5 on rich. All right, so then the expected. Well, here's where the math is, and if you remember in our notes, we had to multiply row total times column total over the grand total or sample size. So what I'm going to have to do here is type the pivot cell names with those totals in them, and then repeat that, unfortunately, 7 more times. So right here, to get the expected count, this is from row 1, so the total is sitting over here in cell I3. So I'm going to do cell I3. Notice it highlights it for me. Times row total times column total. So that's cell E5. And then I have to divide that by the sample size, the grand total, which is in cell I5. Okay, once I hit enter, it gives me the expected count for that spot. I don't really have a quick, easy to explain shortcut for this without too much further knowledge, so unfortunately, just as if I was working this out, I'm going to type in each command one by one. So next I'm on the female happy, so I'd be in this cell. So I wanted to type equals, oh, that's interesting. It's that row total, which has the 18 in it, and then the times key is the asterisk, this column total, and then the divided by symbol is just a slash, and then the cell there. That's faster at least. Okay, and now for the healthy cell, start with an equals. Here's the row total, asterisk, column total, divided by grand total, enter. Female rich, let's type equals. Female rich, here's the row total, asterisk, column total, divided by grand total. Whoops. Gotta press enter. Okay, messed that up. Sorry about that. I'm sure you guys do the same thing. Click in the wrong spot, it messes up the formula and you start again. So male famous, start with equals. Now male famous, it's this row total multiplied by this column total divided by this overall total. Press enter. Everything starts with equals. Male happy, here's the, back up. Row total, clicked again. Row total, asterisk, column total, divided by grand total. Press enter. Next spot in the spreadsheet is male healthy. Start with equals male total asterisk male healthy column total divided by grand total. Okay, so I'm doing this with equations. The efficiency of that is if I had to go and redo this pivot table because some mistake was made, all of these things would update themselves over here if you have typed the formulas like I'm doing here. So equals for male rich, here's the row total, multiplied by the column total, divided by the grand total. Press enter. Okay, so then the next part of the chart is to go get some observed minus expected squareds over expected. This column's a little bit easier. So I can just over here in this first cell type an equal sign, open parentheses. I need the number that's sitting in K2 minus all right, a little pause here because I just noticed that my whole table that I started wasn't in cell J1. Oops. All right, sorry about that. So over here, now I'm going to type equals parentheses. The number that's in K2 is observed minus the number in L2 that's expected. The caret symbol does the squaring, and then I have to divide that back by expected, hit enter, and I have the chi-square part for that. Now because this formula can be updated in each cell, you just have to grab the square corner, paste it down, and notice that when I go here, it did the right thing. It took K3 minus L3, squared it, and divided back by L3. This one, K4 minus L4, squared it, divided back by L4. Okay, and then the remaining instructions are to go put like 2 empty spaces and then type this stuff. So I've got 2 empty spaces here, and now I'm typing a little bit more. So over here I'm typing chi-square statistic. Then I'm typing degrees of freedom. And then I'm typing p-value. So the chi-square statistic, if you remember the formula we were working with in Chapter 10, it's the sum of the squared differences from observed and expected divided back by the expected, all added up. So these 8 things all need to be added up. That's a simple command equals sum. Those numbers are sitting in M2, the 2 dot colon, M9, and my list then is added up. Degrees of freedom, I'm just going to multiply the number of rows minus 1. So that's going to be multiplication of 2 minus 1 times the number of columns minus 1. Famous happy, healthy, rich, that's 4 columns. Remember, you don't count totals. Minus 1. Oops, I forgot the time sign. That's why it's complaining. All right, so I have 3 degrees of freedom. You'll all have the same, potentially. Some of you might notice if nobody responded in one of the categories, you might have a pivot table with 1 less column. So if nobody in your data set wanted to be famous and everybody answered happy, healthy, rich, then your table is going to be a little bit less detailed than mine. It'll have 1 less column in it. So now for the p-value, your final new command in Google Sheets, it's equal CHI SQ dot DIST dot RT, because p-values measures right tail areas, open parentheses, I have to tell it where to get the chi-square statistic from. So I had that chi-square statistic sitting up in cell M12, and I had the degrees of freedom in M13. So M12 and M13, press enter, and I've got my p-value. So once I did this, I set up the chi-square test utilizing spreadsheets and some of their shortcuts, and now I'm ready to make a formal conclusion. So if I ask you to use alpha equals 0.05, that p-value didn't quite come out low enough, I would have a fail to reject HO decision, which means that I have did not find, there is not enough evidence to support the claim that these two variables of gender and preferred life status are related. Okay. Also, I wanted you to notice that some of my expected values in column L here, they did come out to less than 5. That's technically kind of now I have a flawed analysis because this chi-square statistic does rely on certain assumptions, but I did want you to carry out the test anyway, ignoring the violation of those conditions. So back over here, I'm up to this. I did the chi-square analysis over here, got this stuff all typed in, and now I just gave away my conclusion here. All I'm going to do is that steps 8 and 9, a decision and a conclusion in context. Put my name on the page, scan and upload it, and that's it. Woohoo, you guys. As it says here, I'm really proud of everybody for sticking with it. You've all worked hard. I know you've put effort into learning stats. I do hope you learned a lot in my class and wish you all the best success in college and life and beyond. I do hope to see you live and in person at some point to give you some congratulations for a job well done this year. So that's it. Thanks, everybody.